Writing ionic chemical formulas is one of the most important things you need to be able to do in chemistry. Here's how it's done. When two ions combine, their charges are going to cancel out. +1 and -1 cancel out. +2 and -2 cancel out. +3 and -3 cancel out. For example, Na+1 and Cl-1, their charges cancel out, giving a formula of NaCl, known as sodium chloride. Calcium is +2. Oxide is -2. Therefore, they'll cancel each other out to form the formula calcium oxide. X + 3y - 3. Fe is +3. Phosphate, the polyatomic ion, is -3. Therefore, they cancel each other out 1 to 1. A polyatomic ion is one particle that remains together when it's put into a compound. The name of this compound is iron 3 phosphate. Why iron 3? Sodium only has one charge listed. Calcium only had one charge listed. But iron has two charges listed. In this particular compound, iron was +3, so we need to make sure that we indicate that in the name of our compound. We could have iron 2 phosphate or iron 3 phosphate. We happen to have iron 3 phosphate. X + 2 and y - 1. Now these guys don't cancel each other out. So what you do is ask yourself, how many of the smaller charge do you need to cancel out one of the larger charge? Well, it takes two -1s to cancel out a +2, so the formula is XY2. For example, if we happen to have iron +2, remember iron has two possible charges, this is one of them, and let's say we have fluoride, F - 1, then the formula will be FeF2, because it will take two of the smaller charge to cancel out one of the larger charge. The name of this compound is iron 2 fluoride. How many of the smaller charge does it take to cancel out one of the larger charge? It takes 3 -1s to cancel out a +3. So the formula will be XY3. For example, if we have aluminum +3 and nitrate -1, it's going to take 3 of these nitrates to cancel out one of the aluminums. Al parentheses NO3 3. If you have a polyatomic ion and you need to put a number after it, put the polyatomic ion in parentheses and then put the number of those ions outside the parentheses. The name of this compound is aluminum. Now, aluminum only has one charge listed, so you don't need to put a Roman numeral. Nitrate. Now, I wrote phosphate, I wrote nitrate. Where do I get the name of nitrate from? Reference table E, selected polyatomic ions, has all of your polyatomic ions in it. Here's the nitrate ion. NO3- -1 is nitrate. X is +1, Y is -2. Now X is the smaller charge. It takes two +1s to cancel out a -2. X2Y. It takes 3 +1s to cancel out a -3. X3Y. So, for example, if we have potassium, which is +1, and we have sulfate, which is -2. How do I know sulfate is -2? Sulfate, SO4, has a -2 charge, and it's called the sulfate ion. The formula will be K2SO4. Now, you don't need to put parentheses around the sulfate because there's only one of them, and we're not going to be putting a number after it. We have X +1 and Y -3. So let's suppose that we have ammonium, NH4 +1, and as a -3 ion, we have phosphide, P -3. How do we know that phosphide is -3? On the nonmetal side of the periodic table, the top charge that's listed, the first charge, is the ion charge. Now, phosphorus has 3 charges listed. Its ion charge is the top one, -3. The sulfide ion is -2. Chlorine looks like it's got a lot of different charges. The only one that's an ion charge is the -1. The first charge listed is the nonmetal's ion charge. So the formula is NH4 3P. We need to put a parenthesis around the ammonium because we're putting a number after it. X plus 3y minus 2. Now that's a little bit more complicated, so what you do is you multiply these two numbers, and that will represent the total charge you're going to end up with when your formula is written. 3 times 2 is 6, so we want this to be plus 6 and this to be minus 6. How many plus 3's does it take to make plus 6? 2 of them. How many minus 2's does it take to make minus 6? 3 of them. And the formula is x2y3. The same thing goes down here. 2 times 3 is 6. We need plus 6 and minus 6 when we're done with the formula. It takes 3 plus 2's to make plus 6. It takes 2 minus 3's to make minus 6. And x3y2 is our formula. Notice we could do that with any of these. 1 times 2 is 2. We need this to be plus 2. We need that to be minus 2. Therefore, we need 2 plus 1's to make that work. So you can apply this rule to any of the ones that we've done before, unless of course the charge is the same, in which case you just cancel them out 1 to 1. So let's say, for example, that for our plus 3 ion, we have gold, Au plus 3. And Y is the oxide ion, O minus 2. Then you end up with Au2O3. Plus 6, minus 6, and it cancels out. As far as the naming is concerned, K is called potassium. Potassium only has one charge listed, so we don't need a Roman numeral. And SO4 is called sulfate, which you find on reference table E. NH4 is called ammonium. P is called phosphide. Au is called gold. Gold has 2 charges listed, 1 and 3, and this is the plus 3 version, so we call this gold 3 oxide. Let's suppose we have X plus 2, and that's copper, Cu plus 2. And for Y minus 3, we'll use phosphate, PO4 minus 3. We're going to need, 2 times 3 is 6, we're going to need 3 coppers and 2 phosphates. 3 times 2 is 6. 2 times 3 is 6. Our formula is written. Copper has 2 charges listed, 1 and 2. This is the plus 2 version, so this is called copper 2. And PO4 is called phosphate. For our last example, we have plus 4 and minus 2. Well, that's easy. It takes 2 minus 2's to cancel out a plus 4. That's a simple one. So that would come out to XY2. For example, PB plus 4 and S minus 2. We would need 2 minus 2's to make minus 4, which is what cancels out a plus 4. PBS2. Lead is either plus 2 or plus 4. Since this is the plus 4 version, we call this lead 4. And S minus 2 is called sulfide. And those are the basics of formula writing and naming ionic compounds.